So circle answers first. Here we go. What do you think?
X squared plus y squared equals 4.
True.
X plus 3 squared plus y minus 4 squared equals 25.
True.
It's interior.
True.
X minus 3 squared plus x minus 12 squared equals 37.
Small tune-up.
X minus 3 squared plus y minus 12 squared equals 37.
Y on the second group.
Oh.
Yeah, always an X and a Y. Back to the front 5.
Origin
Uh-huh.
and root 30.
True.
1, negative 2, and then 2 root 5.
True.
4 and then negative 2 and 10.
True.
5, negative 6, and root 61.
True.
X squared plus y squared equals 25.
True.
X plus 6 squared plus y minus 7 squared equals 64.
True.
It's on the circle.
True.
Is it 0.25?
Something funny.
X minus 6 squared plus y minus 11 squared equals 58.
True. Can I help anyone do the front?
What do you do on 12?
So we're going to have to figure out the center by averaging the numbers together. So if we average the 3 and the 9, that'll be a 6. So we'll go x minus 6 squared. You with that?
Yeah.
Then the y's, if we average the y's, that'll be an 11. So plus a y minus 11 squared equals. And then what you would do is either plug in the 3-4 pair to what you wrote, or plug in the 9-18 pair to what you wrote, do the subtracting and squaring and adding, and it'll produce a 58.
Okay.
You with that?
Mm-hmm.
Anybody else front? 13, who just went? I think she did, so I think we're even. 13?
0, 0, and root 70.
True.
2, negative 3, root 41.
True.
8, negative 7, and 4.
True.
9, negative 3, root 111.
It is. It feels like that might simplify, and it doesn't.
X squared plus y squared equals 9.
True.
X plus 4 squared plus y minus 5 squared equals 36.
True.
Exterior.
False. No. True. I lied.
X minus 12 squared plus y minus 12 squared, and then I didn't get the answer.
All right. You finish line on that one?
On 20.
On 20?
I had 0.
That's a lot.
17,
That's a lot.
32.
Wait, hold on. 32 is a truth. Yes. Fixing my own mistakes on brand new worksheets that I never had. I missed number 19. I wrote 49 and 16 down and then wrote interior for some reason, even though that's clearly above 55. It distracted me for a minute. 20, we said, yeah, it was equal to 32. I agree with that. 21?
Origin, 2
Yep.
root 15.
True.
9, negative 8, 2 root 3.
True.
2, negative 10, 1.
True.
6, negative 4, root 41.
True. I think it was retreat day that I created and did all these sheets. I think the whole 2-week seminar you're doing, I did this in a day.
Nice.
So I'm not surprised that there's a stray mistake here or there. That's a big volume of math to do in a day. I think was it that day? I told that story once. There's some, I don't know what other day I'd have been that uninvolved. Anything there? Questions, stuff?
20.
20. Were you okay with 12, 12?
Yeah.
Okay, and then if you plug in 8 minus 12s, that'll be 4s. Squareds are 16s, and then 32 when you add. Or if you plugged in the 16s, it's still 4s to get squared in that. You with it?
What was number 3?
Number 3 was interior,
Okay.
because 4 plus 16 falls short. Anybody else sheet life? Alrighty, so notes of the day, we're graphing quadratic equations. So quadratic is algebra code for, anybody remember?
Use.
Eventually when we get to graphs, yeah. But in terms
Squared.
of squares, anything with an x squared or something squared, those are called quadratic. I don't know why that is. I should research that if I'm going to spend my life teaching math, because quad usually means 4. So why it's 2 power is quad anything, I'm not sure where that came from. But quadratic equations have x squareds in them. You might think quadratic formula, your calculator, your quadratic program that we wrote, that kind of stuff. But quadratic just means it's x squared. Joseph correctly remembered, x squared graphs are all going to be U-shapes. So what we're going to do on this is graph a bunch of U-shapes. For number 1, I'll be a little picky about the first one we graph. Am I on camera to here?
Yes.
Am I good? The first U shape we do, I'd like to see about 5 dots just to make sure we're getting the right shape. Beyond that, I'm good with just 1 point, draw a random U. I don't care if you spend a lot of time making this shape we're about to make over and over and over again. But I'd like to do it precisely once. A thought on where we go with this shape, where we are?
Like 1 right, 1 up.
It is. Right 1, up 1, we would have a dot there because
Left
1
1.
squared is 1.
Left 1 up 1.
Left 1, up 1 would have a matching dot because there's a thing that starts with S that these sides match each other.
Symmetry.
It's called symmetry, so we have symmetry working for us. The most obvious dot we didn't do yet
Origin.
is origin, so we're usually that's called the vertex of the U, is usually at the origin.
Right 2 up 4.
Right 2 up 4 because 2
Squared is 4.
squared is 4.
And then same thing on the other side.
And then let's use symmetry to go to the other side. So let's do one nice U to start our sheet that has those 5 dots. And then let's just kind of know the rest of these are going to be the same shape a lot of the time. It's just going to get moved around. Question about 1, exactness. Let's skip 2 for a second and just go to 3. Anybody remember how the graph changes for number 3 when I add a +2 at the end, just kind of loose?
Goes up 2.
It does go up 2. So what we would do is just basically take this graph and push it up 2 squares. So go up 2 above the origin to make the dot that's called the vertex, the bottom of the U, and then just draw a U out of that. I don't care that you try to mimic that exact shape the way we did on 1. So somebody else, where would you think number 5 would go? Down 3. So go down 3, make a dot, and just draw a random U. 7 is not going up or down because it's got these parentheses, the appearance of this has changed. So if I'm not going up or down, I must be going
Left or right.
Left or right. And the question is, do people remember whether that
It's
one
left,
it is
right?
left. Anything with parentheses involved always goes to like the opposite effect of what you would expect it to do. It's going to go left 4, make a dot, and then just make your U shape. One way you could think of this is if you tried to plug in +4. +4 would get you some numbers that are going to be pretty big, like 4 + 4, and then you square it, that's like big. But if you put in -4 + 4 makes 0. -4 is really playing kind of like the role that 0 is used to playing. So -4, in other words, left 4, that's like your 0 location, your vertex location on 7. Question about front. Back 9, where do you think?
Right 5.
It is right 5, so go right 5, make a dot, throw a U on there. 11 is not just moving it. What's different about the equation in 11? So we've got a different impact.
Making it, is it taller?
It's making it taller. So 11, we're going to go twice as tall. So this is another one I'd want to see the dots. If we go twice as tall, would we still start at the origin?
Yes.
Yes. Instead of over 1 up 1,
Over 1 up 2.
over 1 up 2. And instead of over 2 up 4,
Over 2 up 8.
over 2 up 8. If you just make those 3 dots, I'm cool with that because
It's flipped, same thing.
symmetry on the other side. So 3 dots is enough for me on 10. How about, or on 11. 13 is not a tallness issue because now we see the parentheses, and as described earlier, it's going a different way and it always has the opposite impact. So 13, what do you think?
It's 2 times wider.
That's warm.
Half as wide?
What?
Half as wide?
Half as wide. Because we're going to go the like opposite impact in direction and also the opposite impact of like what it feels like it should do. It's half as wide. So would we still be at the origin?
Yes.
Yes. Instead of over 1 up 1,
Over half up
over
1.
half a square and up 1.
And then over 1 up 4.
And then over 1 full square to go up 4. Just do the dots for the right half of the U. And then symmetry gives away the other half. And then 15 I double dipped. I've got 2 things going. What's the minus 1 do?
Right 1.
Right 1 as well as
Down 2.
down 2. So just take this same shape and like push its bottom into quadrant 4, right 1, down 2. And then we're halfway home. Why did I pick that half first?
Because it's all y equals.
They were all y equals. So all y equals u's go that way. Then we'll double back and do x equals in a second. But anybody have a question about any of the odd ones before we go make a change on you? So if y equals u's go this way. X equals u's,
Sideways.
they go nappy time. It's just switching basically the x and y axis. We're just going to go and have a u that just laid down to take a nap. So 2, let's do all of the exact dots. I'll do that one once on the board. Still using the origin?
Yeah.
Yeah. Still over 1 up 1?
Yeah.
Yeah. But where's its mirror?
Down 1.
Down 1. And then where's that 4 thing going to be?
Right 4.
Right 4
Over up 2.
going up 2.
And down 2.
And then the mirror would be underneath. And we got nap time. Where do you think 4 would go?
Is it right 2?
It is right 2. If you lose your train of thought, plug in a number and see what happens. What's your favorite number to plug in?
0.
0. So for 4, if you plugged in 0 for y, it would give you an x
Of 2.
of 2. And therefore, 0, 2 is a point on this u, go right 2. If you get 4 right, then 6 is easy money. If 4 was going right 2, 6 must go
Left 3.
left 3. So go left 3, make your dot, draw your u. 8, we know it's not going right or left anymore
It's
because
going down.
we've got parentheses. This one is going to go down 4. If you're not as instantly sure as he was, if you plug in negative 4 for y, x would come out as a 0, and that is a point that's down 4, and that would kind of give that away. So 8 is down 4, make our taking a nap u. Question on front face? Okay, so where is 10?
Up 5.
Up 5. So we go up 5, same kind of u. 12.
3 times as tall.
And it's also
Flip.
flipped. So instead of opening up this way, it's going to open that way. And it's going to stretch by a factor of 3 this way. It's like natural direction. So instead of have these dots right 1, these dots are going left 3. And instead of the finish line being right 4, it's instead left 12. So we're going to get a really pretty stretched out in that direction graph to be flipped and to be 3 times taller. So what would 14 do?
Half or a third as wide.
Try again.
Or that's 3 times as wide.
3 times as wide. So, still be at the origin. Where would this dot shift to instead be?
3 up, 1
Up
over.
3.
1 over.
It would still be in the 1 over position, but it would be up 3 instead. And its friend would go down 3. How about these that used to have heights of 2s?
6.
They've got heights of 6s. They're still lined up with 4, but 6 is their location now. Then 16, I double dipped you. Anybody 16, spot where the vertex would slam over to?
Up 1.
Yeah. Agreed, up 1, left 2. If you lose your train of thought on the logic of this, I'd plug in some numbers. I would think to myself, if I plugged in a y of 1, my math would get real simple, because I'd be squaring 0. Putting in a y of 1 would yield an x of negative 2. So if I find a point that has a y of 1 and an x of negative 2, I'm on a good path to being correct on this. But we're left 2 squares, up a square, make a dot, and then it's the same u that everybody else was doing. And that's a wrap on graphing quadratic equations. Everybody's a u. SATs love those. They love the y equals ones more than the x equals ones, but the x equals ones do put in a spot appearance here or there, but I'd say the vast majority of these are generally y equals. That's it.